Ambedkar, kindly mute. Yes. So I start now. बहुत ध्यान से देखना. Once again I will.
यस सर, आ रही है.
Yes. So I will teach you about the basic logic gates. In digital electronics, basically logic gates are used to perform some particular function. For example, let's suppose you have a bulb, okay, or you have a LED, and there are two switches connected from that. You want that any switch press, then my LED will be on. If first switch is pressed, second switch is off, then my LED also glow. If my first switch is off, second switch is on, then my LED also glow. If first and second both switches are on, then my LED also glow. If both switches are off, then only LED not glow. Okay, first condition. Second condition, I want that whenever any switch is off, then only the LED glow. Then if first switch is off, second switch is on, my LED glow. If first switch is on, second switch is off, then LED also glow. If both the switches are on, both the switches are off, then LED also glow. If both the switches are on, then only my LED will not glow. Second condition हो गई. Now my third condition is what? When both the switches are at the same position, then only LED glow. It means if first switch is on, second switch is also on, then my LED glow. If first switch is off, second switch is also off, then my LED glow. But if first switch is on, second is off, then LED not glow. If first switch is off, second is on, then my LED also not glow. So this is third condition. Let's suppose my fourth condition is what? When both the switches are at the same position, then my LED will not glow. If first switch is on, second is on, LED not glow. First switch is off, second switch is off, LED also not glow. If first is on, second is off, then LED glow. If first is off, second is on, then LED glow. So these are several kind of combinations. In digital electronics, we can perform all of these kind of applications with the help of logic gates, because each logic gate performs a unique function, right? So first of all, how many types of logic gates? Which logic gates are known as universal logic gates? And then what are the different IC number of those logic gates, the symbol of those logic gates, the definition, the truth table, and their equations. So see this MS Paint file first of all, and I will start about the logic gates. Yes. Okay. So this MS Paint file show you about the different kind of logic gates. Yes. So my today topic is definitely it's logic gates. Right. So how many types of logic gates are there? So basically the different kind of logic gates are, I write down the name: NAND gate, NOR gate, NOT gate, AND gate, OR gate, XNOR. Actually, it is known as exclusive NOR gate. When I will explain you, at that time I write down the full name. Alright. NOT gate, OR gate, AND gate, NAND gate, NOR gate, XOR gate and XNOR gate. These are different kind of logic gates. Actually, these are different ICs. Actually, these all are different ICs of 16 bits, right? When you just go to market, you just purchase ICs for those logic gates. So, what are the IC numbers of those logic gates? First of all, what are the different IC number of those logic gates? Okay. So, first of all, I will explain you about the different logic gates ICs numbers. So, see very carefully, these are different kind of logic gates. Now, which are the universal logic gates among these? Which are the universal logic gates among these? Then remember one thing, that NAND gate and NOR gate are known as universal logic gates. This NAND gate is a universal logic gate, as well as this NOR gate is a universal logic gate. What is the meaning of these universal logic gates? These are universal logic gates. NAND gate and NOR gate are known as universal logic gate. NAND gate and NOR gate are known as universal logic gates. They are known as universal logic gates. Why? Because what is the meaning of universal logic gate? Because with the help of NAND gate and NOR gate, we can realize all other logic gates. NAND गेट और NOR गेट की हेल्प से हम किसी भी दूसरे लॉजिक गेट्स को बना सकते हैं, एंड बना सकते हैं, और बना सकते हैं, एक्सोर बना सकते हैं, XNOR, because we can realize all other logic gates with the help of these gates. That's why they are known as universal logic gates. So frequently asked objective question is, for example, how many kind of logic gates are there? Yeah, which one is known as universal logic gate? Then NAND gate and NOR gate are universal logic gates. Now one by one we will do the each thing. First of all, let's suppose for NAND gate. NAND gate. So what is the basic symbol? I am explaining you about the full detail of each logic gate one by one. First of all, let's suppose NAND gate. So which IC you prefer when you go to market? Which IC you purchase for NAND gate? Then IC series 7400. 7400 IC belongs from NAND gate. Okay. Which IC you purchase for NOT gate? Yes. So remember, 7402 IC you purchase from NOR gate. These are for objective preparation, that which IC belongs from what logic gate. Okay. So which IC? 7402. Which IC you purchase for NOT gate? Then IC 7404 you purchase for NOT gate. It belongs from NOT gate. Which IC for AND gate? Then IC 7408 is of AND gate. Which IC for OR gate? Which IC for OR gate? Then remember, your IC 7432 belongs from OR gate. So IC, NOR gate, NOT gate, AND gate, OR gate. Now what is XNOR and XOR IC? So XOR gate IC is 7486, IC 7486, and IC 74266 is for your XNOR, okay. The 7486 is XOR, and IC for XOR gate we purchase IC 74266. So first of all, which IC belong from which logic gates? So we just take certain examples, certain IC There are so many kind of IC like the TTL, transistor logic ICs. They are of starting from the number 4, but here we describe the ICs which belongs from 74 family. So 7400 is for NAND gate, 7402 is for NOR gate, 7404 is for NOT gate, 7408 for gate, OR gate is 7432, XOR gate is 7486, and XNOR gate is 74266. Okay. Now we discuss about the basic symbols of different logic gates, the basic symbols of these different logic gates. So one by one we solve them. Okay, one by one we see the detail of different logic gates. Okay, I write it. First of all, we start from, let's suppose, NAND gate. So what is the basic symbol of a NAND gate? NAND gate is just a straight line. Now see, this is the basic symbol. Very carefully see this one. This is the input lines. First, there are 2 inputs. And 1 output. 2 inputs and 1 output. This is the symbol of NAND gate. Always remember, throughout the world, whenever you see any book, नमक का पानी पिला दे एक बार, ठीक है ना? नहीं तो फिर मैं आऊँगा हॉस्पिटल देखूंगा, है ना? ठीक ठीक। भी ठीक है, 2 बार उल्टी है। हेलो, yes. So NAND gate is IC 7400 IC. Okay, A and B are 2 inputs and Y is my output. So what is the basic definition of a NAND gate? How can we understand about the NAND gate? So I write down the basic definition so that you can understand the meaning of NAND gate. So NAND gate is what? Whenever any input is 0, output is 1. Whenever any input means it may be A, it may be B, or it may be A and B both. Okay, any input is 1, sorry, any input is 0, then output is 1. Remember, this is the basic definition of an AND gate. Whenever any input is 0, then output is 1. This is the basic definition of a NAND gate. This is the basic definition of NAND gate, that whenever any input is 1, output is 1. Okay. What is the output equation for a NAND gate? What is the equation so that we can represent the NAND gate? So Y is equal to A dot B. A dot B having a bar over there, having a bar over there, having a bar over there. Y is equal to A dot B having a bar over there. This is the basic equation of a NAND gate. What is the IC number? 7400. What is the symbol? Symbol I just draw here. Whenever any input is 0, output is 1. Now we talk about the characteristics table, the truth table. Now we talk about the truth table of NAND gate. So what is the truth table? we will see in all logic gates IC number, symbol, equation, definition and truth table. Okay. So what is the truth table for a NAND gate? In truth table we represent the input and output. So see very carefully, with the help of the definition we can easily draw the truth table, we can easily make a truth table. Now see, here is my inputs. See very carefully now, if you will not understand, then okay, inputs and outputs. How many number of inputs are in NAND gate? A and B, two inputs. So A and B, two inputs. And what is the output? My output is Y. Okay. Now whenever two input are there, how many number of combinations are there? Either both are 0 0, either both first is 0, second is 1, or first is 1, second is 0, either both are 1 1. These four combinations are there. Okay. Now see, let's suppose first is 0, second is 0. Let's suppose first is 0 but second is 1. See very carefully, either first is 1, second is 0, or the last one is both are 1 1. These four possible combinations are there. Now see very carefully, what I wrote in this definition, that any input is 0, output is 1. Any input is 0, output is 1. So see, A is 0, B is 0. So 0 we see in any input is 0, any means either A, either B or both of them, any one. So you see 0, so just write down 1. Okay. Here A is 0, B is 1. So 1 0 you find, so write down 1. Whenever see any 0, just write down 1 at output. A is 1, B is 0. Now again you see 0, so write down 1. Now in this case, A is 1, B is also 1, both are 1, no 0 we find, that's why output is 0. Okay. So this is the basic truth table of the NAND gate: IC number, symbol, definition, equation and truth table. So all about NAND gate is completed. Basics of all about NAND gate is completed. So if you understand the NAND gate, kindly write down yes in message box. If you understand about the truth table, symbol, equation and basic definition, how we make the truth table, then kindly write down yes in message box so I understand. Amit Ashish Ambedkar. Yes, Ambedkar. Okay, okay, very good. Now we see the second one. So this one is NAND gate. Now we will again see the second logic gate. Okay, now I write down them in a. Okay. So you just see, kindly take a snapshot and keep it with you so I can remove these from here. Now I am explaining you about NOR gate. Okay. Now I am explaining you about NOR gate. See very carefully. Now see, NOR gate is what? NOR gate, so I told you about the IC number. IC number is 7402. IC number is 7402. Okay. Now first of all, what is the basic symbol of a NOR gate? What is the basic symbol of a NOR gate? Then NOR gate is like this one. First I start with NAND and NOR because they are universal logic gate. With the help of these logic gates we can build any other logic gates. I have already been mentioned that NAND gate and NOR gate are universal logic gates. They are universal logic gates. So now I am explaining you about the NOR gate IC. See, this is the symbol of NOR gate. This is the symbol for NOR gate. Again here this, A and B are my inputs and Y is my output. A and B are my inputs and Y is my outputs. Okay. Now what is the equation? The equation for NOR gate is, remember, Y is equal to A plus B having a bar over there, having a bar over there. A plus B having a bar over there, that is my OR gate, NOR gate. A plus B having a bar over there, that is my NOR gate. Now what is the basic definition of NOR gate? Whenever any input is 1, output is 0, or we can say whenever both input are 0, output is 1. Anything you can remember. So whenever any input is 1, output is 0. Whenever any input is 1, output is 0. Whenever any input is 1, output is 0. This is the basic definition of a NOR gate. In NAND gate you see whenever any input is 0, then output is 1. But here whenever any input is 1, then output is 0. Okay. Now I am showing you the truth table. So first of all I just copy paste and then remove some data over there. Okay. So let's suppose I am going to draw the truth table. Because there are 4 inputs, so all the combinations are as it is 0 0 0 1, either A is 0, first input is 0, second is 1, either first input is 1, second is 0, either both input are 0, either both input are 1. Okay. But what is the truth table now? From the definition of NOR gate, we see any input is 1, output is 0. Any input is 1, output is 0. So see, first both are 0 0, it means no 1, there is no 1. Whenever you see any 1, then write down 0, otherwise 1. So 0 0, so there is no 1, so I type here 1. This is my output. Here 0 1, you see 1, you find 1, whenever you see any 1, just type 0. 1 0, again you find 1, so just type 0 at the output. 1 1, again you find 1, again type 0. So this is the truth table. These are the outputs combinations for the input. 0 0, then output is 1 because there is no 1 at the input side. 0 1, then 0 because 1 is there. 1 0, again 1 is there, so we type 0. 1 1, then I have to type 0. Okay. So this is the basic about the NOR gate. So what is the symbol of NOR gate, what is the equation of NOR gate, what is the IC number of NOR gate, what is the definition, and what is the truth table of NOR gate. We will prove in laboratory also. During afternoon session there will be a lab of digital electronics. So in that lab we will perform the NAND gate, NOR gate, logic gates first practical over. So we will build the circuits, we connected the lights, we connected the switch, and we see that if we perform the practical of NOR gate, then we will see that whenever any input is 1, then output will be 0. It means whenever input lights are on, then output light is always off. You will see. So this is all about NOR gate.